Welcome to Brain Vision.
So in problem 47, we're given an aqueous NaCl solution. And we need to calculate molarity, and mass percent of a given solution. So let's start by writing down what we are given. We're given the mass of the solute, which is NaCl, which is 112 grams. We're given the total volume of the solution. It's 1.0 liters. We're also given the density of the solution, which I will just mark as D, is 1.00 grams per milliliters. So yeah, this is what we know. And now let's start with calculating what we need to find out. So we know that molarity of a solution is defined as the amount of the solute in mole divided by volume of solution. So the value that's still missing is the amount of the solute, but we know from previous problems, we know that the amount of the solute equals to the mass of the solute divided by the molar mass. So if we substitute this into the equation above, we'll end up with molarity being equal to mass divided by molar mass, and this whole thing divided by the volume of the solution. Let's put in some values. We know that the mass of the solute is 112 grams. We know that the molar mass of NaCl is 58.44 grams per mole. Let's just shift. So we'll put that into our equation. .44 grams per mole, and divide it all by 0.0 liters. And this results in our molarity being 1.95 moles. And this is the first answer. So now we can talk about molality. So here's again the equation that we need to use, which is molality is equal to amount of the solute divided by mass of the solvent. Here, it's very important that it's mass of the solvent and the mass, and not the mass of the total solution, because it will actually make a difference. So again, as on the previous slide, we can just replace the amount of the solute with mass divided by the molar mass, and we can calculate the the mass of the solvent by calculating the mass of the solution by subtracting the mass of the solute out of the total mass of the solution. And if that's not clear, I will actually write it all out. So it will become. So again, I will write here in the corner what we're given so that we don't lose track. Here we are. So we can calculate the mass of the solvent by subtracting absolute from the solution. The solution will obtain by multiplying the volume of the solution by the density. So it will actually be 1.08 kilograms. And then the mass of solvent is actually 1.08 kilograms minus 0.112 kilograms. And I just converted grams into kilograms for an easier calculation. And then we actually get 0.968 kilograms of the solvent. So let's put it all into this equation. So again, we have amount of solute as mass divided by molar mass. Divided by solvent, which is 112 grams divided by 58.44 grams per mole, divided by calculated 0.968 kilograms. Let me just shift this upwards. And this will be equal to roughly 2.0 mole per kilogram molality. Okay, so this is the end result. Okay, let's move on to the next point, which is the weight percentage, which is probably the easier thing to determine. So again, weight percentage is defined as mass solute divided by mass solution, and not the solvent. Again, very important, multiplied by 100%. And actually, all of these values we have. So we know that the mass of NaCl is 112 grams. We know that the mass of our solution is 1.08 Yeah, actually, let's convert it to grams. So it will be 1080 grams. And we'll multiply this whole thing by 100%. And then we end up with the weight percentage of the solution being 10.4%. Okay, so we answered all of the questions. The weight percentage is 10.4%. The molality is 2.0 mole per kilograms. And the molarity is 1.95